Now that we know about the solubility rules, we're able to write and predict what will happen in double displacement reactions. A double displacement reaction will occur. Two ionic compounds react with each other. And this is usually in water. This reaction can actually very rarely take place when you don't have water. So we have two ionic compounds, and the basic form of this reaction is going to be, if we have compound AB, and we react that with compound CD, the metals of these compounds switch places. So what we end up with, if A and C are the metals, we end up with new compounds CB and AD. So that is the general form of our double displacement reaction. Now there are a few things that have to happen when a double displacement reaction occurs. And to look at those, let's look at an actual example. So we are going to start with lead nitrate and potassium iodide. Lead nitrate and potassium iodide. Once we know that we have two ionic compounds, which we do, both of these compounds have a metal and a nonmetal, we have to check the solubility of the reactants. Check the solubility of the reactants. And what we are looking for is that both reactants must be soluble, which is also aqueous when we're talking about states. In order for the reaction to occur. So the first step, both reactants must be soluble in order for the reaction to occur. So we refer to our solubility rules, and our rules say that all nitrates are soluble, and there are no exceptions with that rule. So that means that lead nitrate is going to be aqueous. And then we look at our rules, and potassium iodide, potassium is an alkali metal, group 1 metal, and all compounds that contain an alkali metal are soluble. So this will also be aqueous, and we pass that test. So we pass the test, both reactants are soluble. The next step is to write the dissociation equation for both reactants. And this is just showing how the compounds break into ions. To do this, let's start with lead nitrate. So PbNO3, 2. And the dissociation equation just means when we put this compound into water, we know because it's soluble, it will split into ions. So we have lead ions, and those ions we need to figure out its charge. So well, we know that there's also a nitrate ion. And nitrate, according to our chart of polyatomic ions, has a -1 charge. And since we have 2, we have a total of -2 for our nitrate charge, meaning our lead must be +2. And I should balance this so I can put a 2 here. So lead nitrate breaks into a lead ion and 2 nitrate ions. I am then going to do the same thing with potassium iodide. So I have potassium iodide, Ki. It's soluble, so it's going to break up into potassium. I know potassium has a +1 charge because it's on the periodic table, plus iodide, which has a -1 charge. Once I've written these dissociation equations, I'm going to swap the ions and balance the charges on the new compounds. So swap the ions and balance the charges. The reason we're swapping these ions, so when I say swap, lead is now going to form a compound with iodide, and potassium is going to form a compound with the nitrate. And think of this as both of these compounds have split up and all of these ions are in water. So they can all bump into each other. If lead bumps into nitrate, we already know that those are going to break apart. So nothing's going to happen if it bumps back into nitrate. Lead will not bounce into potassium because they're both positively charged. They'll repel each other. So the only possibility of anything happening is this lead bumping into an iodide, maybe something will occur, and this potassium bumping into a nitrate. Maybe a reaction occurs. So we'll write these compounds lead with iodide, and we have to balance our charges. So I'll write these as our product. So lead plus iodide gives me PbI2. I need 2 -1 charges to balance the positive charge. And potassium nitrate, KNO3. They both have a +1 charge, -1 charge. So that is the formula. So we're saying, okay, these ions, they're bouncing around when they're dissolved in water. Sometimes they bump into each other, and sometimes they will form these new compounds. The last step that I have to do is check the solubility of the products. And in order for a reaction to occur, at least one product must be insoluble, or a solid in the equation, for the reaction to occur. When we're going through this process, if steps number 1 and 4 do not hold true, there is no reaction. And we write no reaction as NR. So now we have to check these solubilities. So if we look at our solubility rules, we will see that iodides are soluble except when with lead. So because of that except, lead iodide is a solid. Potassium nitrate has an alkali group 1 metal and a nitrate ion, both of which make it soluble, so this will be aqueous. So a reaction will occur because we have at least one solid product. The reason why we have to have at least one solid product is if both products were aqueous, were soluble, they would split up again into the ions, and once they're split up, they'll bounce around, bump into each other, but no combination will actually form a new compound, so nothing really occurs. So the only way for a reaction to happen is if a new substance forms, and for that to happen, it has to come out as a solid, so it doesn't separate out. And this solid product is called the precipitate. Why is it called the precipitate? Well, when this solid forms, solids are more dense usually than liquid water, so it's going to fall to the bottom. So this solution was actually the reaction we looked at. It was aqueous lead nitrate with potassium iodide, and when those lead ions bump into the iodide ions, they form a solid, an insoluble lead iodide solid, which falls to the bottom. So here's a cartoon example, and if you let this sit for a while, all of the solid will end on the bottom, with all of the remaining dissolved potassium and nitrate ions up in the supernate, or solution above the precipitate.